Hello everyone, my name is Pavani. In this video, I'm going to show you how to solve an optimization problem using Excel. Let's see what the business problem is all about. The marketing manager for Mountain Mist Soda needs to decide how many TV spots and magazine ads to run during the next quarter. He has received a report from his subordinate that each TV spot costs $5,000 and is expected to increase sales by 3 lakh cans. Each magazine ad costs $2,000 and is expected to increase sales by 5 lakh cans. He has got an approval from the top management to spend a total of $1 lakh on both TV and magazine ads together. However, the marketing manager wants to spend no more than $70,000 on TV spots and no more than $50,000 on magazine ads. Mountain Mist earns a profit of $0.05 on each can it sells. Figure out how the subordinate could have come across with the values highlighted in yellow. Figure out how the top management have come to a decision to allocate $1 lakh for this purpose of marketing. Figure out how the manager could have come across with the values highlighted in green. Figure out how the profit margin of $0.05 could have been obtained. Formulate an LP model for this problem. Sketch the feasible region for this model. Find the optimal solution to the problem using level curves. To solve this problem, let's first try to understand what the constraints are. Each TV spot costs $5,000 and each magazine ad costs $2,000. Also, the marketing manager do not want to spend more than $70,000 on TV spots and no more than $50,000 on magazine ads. The marketing manager had also got an approval from the top management that he cannot spend more than $1 lakh for the complete marketing campaign. If we assume x1 to be the number of units of TV spots and x2 to be the number of units of magazine ads, we can write the constraints as shown below. Each unit of TV spot is set to increase the sales by 3 lakh cans. Each unit of magazine ad increases sales by 5 lakh cans. Subject to the constraints given in the problem, we have the following linear inequalities or linear inequations. That is 5,000 into x1 less than or equal to 70,000. That means the optimum spend on TV spots cannot go beyond $70,000. The next constraint is 2,000 into x2 less than or equal to 50,000. That means the optimum spend on magazine ads cannot go beyond $50,000. And the third constraint is the total optimum spend on both TV spots and magazine ads together cannot go beyond $1 lakh. And the profit equation is given by $0.05. That means the profit earned by each can sold by the company multiplied by the total number of units sold after the marketing campaign, which is given by 3 lakh units into x1 plus 5 lakh units into x2. For the given constraints, we can also calculate the maximum number of units of TV spots and magazine ads, which implies that x1 cannot go beyond 14 units, which means that we cannot spend more than which means we cannot go for more than 14 units of TV spots and we cannot go for more than 25 units of magazine ads. If we try to represent all the three constraints in a graphical form, we may get a solution which is similar to this. The first constraint, that is 5,000 into x1 less than or equal to 70,000, may be represented with this vertical line. From this equation, we will understand that x1 cannot go beyond 14 units, so the region towards the left is the feasible region for first constraint. The second constraint is 2,000 into x2 less than or equal to 50,000. From this equation, we can understand that x2 cannot go beyond 25. So the feasible region is given by the region which is below this particular horizontal line. And the third constraint, that is 5,000 into x1 plus 2,000 into x2 is less than or equal to $1 lakh, can be represented by the slanting line. So the feasible region or the optimal solution for this problem is represented by this shaded portion. So let's try to find out what the optimal solution is by using Excel. Here, the cost incurred by each TV spot is $5,000 and by each magazine ad is $2,000. And the number of units increased by each TV spot is given by 3 lakhs and by each magazine ad is given by 5 lakhs. Here the decision variables are the number of units of TV spots and magazine ads, or in turn X1 and X2. TV spots represent X1 and magazine ads represent X2. Here we have the constraints. The first constraint is the optimum spend on TV spots cannot go beyond $70,000. The optimum spend on TV spots is given by B16, that is $5,000 on each TV spot into the number of units of TV spot. Cannot go beyond $70,000. The next constraint is the optimum spend on magazine ads cannot go beyond $50,000. The optimum spend is given by C17, that is $2,000 on each magazine ad multiplied by the total number of units of magazine ads. The third constraint is the total spend on both TV spots and magazine ads together cannot go beyond $1 lakh. And this optimum spend is given by B15, that is cost incurred by each TV spot into the total number of units of TV spots plus 2000. That means the cost incurred by each magazine ad multiplied by the total number of units of magazine ads. It shouldn't go beyond $1 lakh. And the profit equation is given by 0.05 into the total number of units of soda sold after the marketing campaign, which is given by B4 into B10, that means the total number of units of TV spots, plus C4, that is 5 lakhs, into the total number of magazine ads. Now, these are the decision variables. Depending on the values here, the values in these particular cells, that is D15, 16, 17, and the profit, which is given by E10, all these 4 cell values will change. Let's see how. Suppose you increase the number of units of TV spots to say 10 and the number of magazine ads to maybe 20. You see that the values in these particular 4 cells are changing. Now you can find the optimum number of TV spots and magazine ads to get the maximum profit by using a solver. You'll find the solver tool under data tab here. So for solver, we need to mention the objective first. Our objective for this problem is to maximize the profit. The profit is given with E10 cell, and we need to select maximum because the objective is to maximize the profit under the given constraints. Next, we need to mention the variables which have to be changed. That means B10 and B11, because only by changing these two particular cell values the Excel can actually find out what the optimum solution to maximize the profit for this problem is. Next, we have to give the constraints. To give the constraints, click on Add. The first constraint is given by this particular cell value cannot go beyond $70,000. Click on Add. The next constraint is this particular cell value cannot go beyond $50,000. Click on Add. The third constraint is this particular cell value, that is the optimum cost, cannot go beyond $1 lakh. Click on Add, then click on Close, and then we'll have the Excel solver. Just check all the constraints and values and then click on Solve. See, here we get the optimum solution given by the Excel solver to get the maximum profit under all the three constraints. So the optimum number of TV spots that we can go for is 10 units, and the optimum number of magazine ads that we can go for is 25 units. We can keep the solver solution if we want to, or we can just ignore it. Thank you for watching.